Okay, so 9.2 is talking about inverse functions, and basically we're going to discuss whether the function is one-to-one. So, interchanging the first and second coordinates of each ordered pair in a relation produces the inverse relation. So basically what you're doing is you're taking your x and you're putting your x where your y is, and you're taking your y and you're putting it where your x is. So the inverse function would be y comma x. So if it's 2, 4, it's going to become 4, 2. If it's negative 1, 3, it's going to become 3, negative 1. If it's negative 2, 0, it's going to be 0, negative 2, flipping them. If a relation is defined by an equation, interchanging the variables produces an equation of the inverse relation. So find an equation for the inverse of the relation y equals x squared minus 2. So instead of y, so I'm going to write this over here. So instead of y, that's going to change to an x equals x squared. Well, if this is an x squared, then this is going to be y squared minus 2 minus 2. All we've done is taken the y and put it where the x is, and taking the x and put it where the y is. So we have this thing called a special thing called one-to-one, and it says if a function is one-to-one, if different inputs have different, it is one-to-one if different inputs have different outputs. That is, if a is not equal to b, then f of a is not equal to f of b. Or a function is one-to-one if when the inputs are the same, the outputs, if when the inputs are the same, the inputs are the same, that is, f of a is equal to f of b, and a is equal to b. So, that's kind of confusing. Let's just talk about it with something that's a little bit more like a picture. So we talked about that if something's a function, that all the x's have to be different if it is a function. Okay, so when we start writing, so this is definitely a function because we've got 0, 4, and negative 6 in the x column, and none of those things are the same. If I switch this around and do the inverse, if I do 7 goes to 0, and 2 goes to 4, and negative 1 goes to negative 6, then it's easy to see that my x's are still going to be different even in the inverse function, 7, 2, and negative 1. But on this one over here, all the x's are different, 1, negative 4, and 6. But when I switch them around, I would have 0, 1, 0, negative 4, and 10, 6. Well, I've got a problem because I've got two zeros here. So this is not a function. The inverse here is not a function. So both f and h shown above are functions, but which one is one-to-one? So the answer to that is f, because it has to be a function. In order to be one-to-one, the original function has to be a function, okay? The original relation has to be a function, and the inverse relation has to be a function. So both of these all have x's that are different. This is not a function, so it's not one-to-one. Okay? So, why do we care about a one-to-one function? If a function f is one-to-one, then its inverse is also a function. If the inverse of a function is also a function, it is named f inverse. The negative 1 in f inverse is not an exponent. It does not mean the reciprocal of f. So if a function is one-to-one, then its inverse is a function. The domain of a one-to-one function is the range of the inverse of the function. The range of a one-to-one function is the domain of the inverse of the function. A function that is increasing over its entire domain or is decreasing over the entire domain is a one-to-one function. Those are just some things we already know. Okay, so when we were doing a vertical line test to tell if something was a function. So if we look at this, I can go pretty quickly and go, okay, this right here only touches one time, so it is a function. This one touches one time. It doesn't matter where I draw the line. It only touches one time. This would be a function. This is a function. It only touches one time. This is a function. It only touches one time. So that helped me determine if these are all functions. To determine if they're one-to-one, I'm also going to have to do a horizontal line test. And this only touches once, so it is one-to-one. This one touches twice, so not one-to-one. It does not pass the horizontal line test. This only touches once, so it is one-to-one. This touches multiple times, so it is not one-to-one. So in order for a function to be one-to-one, it has to pass the horizontal and the vertical line test. So let's work some problems with this one-to-one functions and inverses. So to determine whether the function f of x equals 2x minus 3 is one-to-one, it wants us to determine that. Well, first off, I can tell that I can draw a vertical line and a horizontal line, and it will only touch it one time, so it is one-to-one. So they want us to find the inverse. So right now, it says f of x equals 2x minus 3. So the first step is to replace the f of x with y. The second step is to wherever you see an x, you're going to make it a y. And wherever you see a y, you're going to make it an x. So this y would change into an x. This x would change into a y. And then we're supposed to solve this for y. We're supposed to get it to say y equals. In order to do that, we're going to add 3. We're going to move everything away from this y, this 2y. So that's going to be x plus 3 equals 2y. We're going to need to divide by 2. And so the 2's cancel out, and we would get y is equal to x plus 3 over 2. And then finally, we're going to replace that f of x with the inverse. We're going to replace our y with the inverse of x is equal to x plus 3 over 2. Okay. If I've got a graph, I know it's one-to-one because if I draw a vertical line, it would only touch it one time. And if I draw a horizontal line, it would only touch it one time. So I should be able to find the inverse because it is one-to-one. So first thing I'm going to do is I'm going to change my g of x to an f of x. Sorry, I'm going to change my g of x, which means the same thing as y. I'm going to change it to y equals x to the third plus 2. Now I want to interchange my x's and y's, so I would have x equals y to the third plus 2. So now we're going to solve this for y. So we're going to subtract 2. So x take away 2 equals y to the third. To get rid of a y squared, we would take the square root. To get rid of a y to the third, we're going to take a cube root. So I'm taking the cube root of both sides. Okay, and that's going to get me y is equal to the cube root of x minus 2. And we're going to replace that y with f inverse and let me go back because this is not an f. We're using g on this one. So we want to replace that with g inverse -1 of x is equal to the cube root of x minus 2. Okay. So this time we don't have a graph. Now I can make a graph on my calculator, okay, but I'm just going to go with what we've been told to do, which was determine whether the function f of x is equal to the square root of x minus 3 is 1-to-1, and if it is, find its inverse. So if it has an inverse, let's go ahead and graph it. So we're going to have the square root of x minus 3. I'm going to go to my graphing calculator. Y equals, second, let's get out of that, clear this out. So we're graphing the square root of x minus 3. And all of that's supposed to be underneath that radical sign or that square root sign, and I'm going to hit graph. There's what it looks like. It looks like it would pass the vertical and the horizontal line test. It wouldn't touch it more than once, so pretty sure about that. I'm just going to make myself a note right here. It passes vertical and horizontal line test. Okay. And then I'm going to say, I'm going to start following the steps. Instead of f of x, I'm going to put y is equal to the square root of x minus 3. Now I'm supposed to switch out my x and y, and then I want to solve for y. So I'm going to I need to get rid of this square root. To get rid of a square root, you need to square both sides. When you square a square root, it kind of undoes it. So we've got x squared equals y minus 3. Add 3. So we would get x squared plus 3 is equal to y. Let me rewrite that. Y is equal to x squared plus 3. The last step is to do f inverse of x is equal to x squared plus 3. Okay, so there's that one. 2 over x plus 4. I'm going to see, does it pass the vertical and the horizontal line test? So I'm going to go to y equals, clear this out, alpha, y equals, enter, 2 over x plus 4, graph that. Okay, so this one looks like we don't have any problems with the vertical or horizontal line test either. So let's see if we can find our function. So we're going to change our y, our f of x to y. So 2 over x plus 4. We're going to switch our x's and y's. So wherever we see a y, we're going to put an x. And wherever we see an x, we're going to put a y. Now I want to solve this for y. So I'm going to do something called cross multiplication. So I'm going to put a 1 underneath here, and I'm going to multiply across the equal sign. So that's going to get me x times y plus 4 is equal to 2 times 1, which is just 2. I'm trying to get y by itself, so I'm going to go ahead and divide by x on both sides. So I'll have y plus 4 is equal to 2 over x. Subtract 4. So I'd have y is equal to 2 over x minus 4. So this is our inverse function. So we would replace the y with an f inverse of x is equal to 2 over x minus 4. So that's how you do 9.2.